Hey everyone, how's it going? I've got another debunk video for you here. Somebody sent me this recently, as it just happened recently. How scientists proved the Earth is round with a bike and two sticks. Buckle up, we're about to get into some real science here, as you can tell. You know, another stick shadow experiment. Let's just take a look at what's going on here. So, a guy named Kurtis wanted to prove that the Earth was indeed round. So he went somewhere flat. That's the first stumbling block that I've found in this whole thing. He wants to prove it's round by going somewhere flat. So he goes to Saskatchewan. If you're not sure what Saskatchewan is, it's a very flat part of Canada. And there's no curvature there. There's no globe there. But he goes there to prove that it's round. I can't get stuck on this for too long or else I'll just end up repeating myself. But he had to go somewhere flat to prove that the Earth is round. I can't overstate the irony. And you know, this is kind of where I feel sorry for people who think the Earth is a ball, because it's almost like the people who are purporting the ball theory to put God away, to put creation away, to get rid of to hide and cover up the flat Earth, the nature of the real Earth that we live on. They don't even have to try anymore. You know, I don't think this guy is in on it. I'm not saying this guy's in on the globe Earth and he knows that it's actually flat. You know, you don't have to be in on it to believe that it's true and to tell others that it's true. You know, think about a bunch of kids surrounding a globe in a classroom and the teacher is saying, look here, this is where we are on the Earth. Those kids aren't in on it, but now they're brainwashed to think that we live on a ball, right? In the same way, I don't think this guy's in on it, but the people who, you know, the enemies of God who present the globe theory to fool you all, they're laughing because they've got this guy. They've just, you know, they've set the dominoes tumbling, and this guy now makes this experiment to prove again that the Earth is a globe. But the evidence is right in your face. This is where I'm getting. The evidence is right in your face. He had to go somewhere flat to prove that it's round. Okay, let's move on. Let's take a breather. What I want to focus on is how he did this experiment. So what he did here, Kevin Baute, I believe it's pronounced. He headed to one of the globe's longest stretches of flat road in Saskatchewan, and he cycled 138 kilometers between the two, or on either end of the 138 kilometers. He set down two sticks, and then he measured the shadows. Okay, so this is the classic. You know, I just actually covered this experiment in my last video, but let's do it again. Apparently, we have to. The problem really starts, if you can ignore the first thing I just went over, the problem really starts with where he says, the sun is very far from the Earth, and the light hits us in parallel lines. According to the globe theory, that would be true. If the sun is 93 million miles away, those light rays should be hitting Earth at parallel angles. Okay? So now then he continues to say, if the Earth was flat and the sun is very far away, then those shadows would be the same length. Alright, so what does that look like? We're going to pull up paint here, and I'm just going to show you. If you've got sun rays coming down, right, and these are the parallel rays from the sun, if you have a stick here and you have a stick here, you know, those shadows are just going to be like, shadow will just be underneath the stick, and the shadow will just be underneath the stick, right, as those rays hit it. That's what he's arguing. But let's take a step back and see what's really going on in his experiment, because I think you'll see at the end of this, he's actually just proven that the Earth is flat, but it's because the shadow, I don't want to spoil it, let's just get out of here and take a look at his video. So what he's done, essentially, is, yeah, he rode 138 kilometers and he has two sticks and the shadows are different lengths. All right, so he's arguing that because the shadows are different lengths, the Earth is round. And here's a summary of why he says that. I'm just going to pull out the image here. This is it. This is why he thinks that the Earth is round, is because on this globe model he's got with the orange here, he's got a stick here, he's got a stick here, and one shadow is obviously very long, and one shadow is quite short. But there's a problem, and this is the problem here. Kevin traveled 138 kilometers and set up these two sticks, and he's got different shadows. Do you know what the distance between these two sticks would be if this were the globe? Let's take a look here. Let's just take a quick Google search and see that the Earth is 40,075, so let's just call it 40,000 kilometers in circumference. This is the circumference, right? So if this is 40,000 kilometers, if you were to slice that in half, you know, obviously you got 20,000 kilometers, so from one side of the orange, or the Earth, to the other side of the orange, or, you know, 20,000 kilometers. So what's the distance between these two sticks? I don't know, maybe if you divide it by thirds, what do we get? 20,000 divided by 3. Uh-oh, sixes. Let's just round up. We're going to call it 7,000 kilometers. There's about 7,000 kilometers between these two sticks. And he's telling us he did an experiment with 138 kilometers in between. Do you know what that looks like? Let's take a look here. If we go to Google Maps, we're going to see that well, I've got 138 kilometers measured out here, just over Africa. That's 138 kilometers. So let's take a look at the high altitude aircraft imagery and see what this really looks like on the globe. I'm going to zoom out slowly. Okay. And wow. Those 2 points sure don't look like these 2 points, do they? Nope, totally different. Globe earthers and flat earthers alike, you can agree on something finally. These 2 points are not the same as these 2 points. So hear what I'm saying. If this represents the Earth, and the sun is 93 million miles away, and it happens to be mostly over this stick, you got a short shadow because of the curve, and those rays are coming down at parallel lines, you've got a long shadow. Right? Because there's a big curve between here and here. But what's happening on the actual experiment is he's so close together here. Let's take a look at what's really going on. So here's the Earth, here are these 2 points, and you want to point the sun at 93 million miles away, right? So let's say the sun is way up here. I can't even begin to, it's not to scale, right? Like the sun's rays are coming down in these parallel lines. These are the parallel sun rays coming down to the Earth, right? Let's zoom back in and take a look here. Those parallel lines coming down on the Earth like this, right? On those 2 sticks. All these sun rays coming from the sun, 93 million miles away, they're parallel. He just said that. And so as they strike the Earth, I actually have reason to believe that on the globe Earth, those shadows should be the same. Notice how backwards this is. He says, if the Earth was flat and the sun was very far away, those shadows would be the same length. Okay, but what's really going on here? On the globe Earth, those two sticks are so close, I could actually expect the shadows to be flat on the globe. Okay, but what actually happened in reality, so let's keep this in mind. What happened in reality was that he set up these 2 sticks 138 kilometers away, and the sticks' shadows were actually different lengths. So there's a discrepancy here, right? Something's not quite right. We know based off of what's really going on to scale, these sun rays coming in from the sun, they should be parallel. And so the shadows, you know, if there were a difference between the 2 sticks, it would be so minuscule, but you could say that they're like the same, you know? Even if the sticks were over here on the edge of the Earth, you know, and the sun rays were coming down the way that I got them drawn here, then the shadows would be longer than they are in this example, but they would still be pretty much the same length, the 2 of them. So no matter what you do on the globe here, you know, you should be seeing similar shadows. What's actually happening though? You're seeing 2 different lengths for the shadows. And so what I think that clearly tells us is that, let's just clear the area here. Alright, so what I have going on here is a model of the flat Earth. There's the firmament on top. In this example, I'm trying to draw it close to what a rainbow looks like, because that's why I think rainbows are the shape that they are, because of the firmament shape. Other people say that the firmament's actually quite low to the ground in comparison to this image. But what I have there at the bottom, you'll see, is about 138 kilometers carved out. If this Earth, the flat Earth, is just an unraveled globe, then it's about 40,000 kilometers in diameter. And so that 138 kilometers is well, as close to scale as I can make it with clunky pixels, right? And I'm just kind of guesstimating and eyeballing, but so you'll see, I'll zoom in here, and you can see that very small carved out section. That's the distance in Saskatchewan that Kevin was working with. And the height of the sun here, again, some people think because the firmament's so low, the sun's quite low to the ground. Well, in the flat Earth theory, no matter what, it's quite low to the ground compared to the globe theory. But I'm guesstimating here, if we cut the Earth in half, width-wise, that's about 20,000, and since the circuit of the sun looks a little lower than half of the width of the Earth, I'm going to say maybe the sun is about 15,000 kilometers high. Now, 15,000, that sounds like a lot, but consider that in the globe model, the sun is supposedly 93 million miles away, and here we're working with 15,000 kilometers. I've also drawn the sun very small, as it is in the flat Earth theory. Some people say it's about 32 miles wide. I don't know. If it is, then it should definitely be smaller, because it's about the same size as the 138 kilometers. So no matter what, the point is that the sun is really small. So what we can do here is start to actually work with a triangle that we are able to actually see and visualize. So if you form a triangle from the two sticks to the sun, you can see that, yeah, it's really pointy. This thing's like a razor blade. But it's still manageable compared to the 93 million mile away sun. So basically, if you consider the surface of the Earth down here in my image, if that's to scale of the globe, if this Earth here was stretched around a ball, it's 40,000 kilometers in circumference. If the sun were 93 million miles away, if you tried to make lines with the shadows to the sticks to the sun, they'd be basically parallel, and then shadows are so blurry as it is, you can't get exact fine measurements, especially if the sun's that far away. In the flat Earth model, you have a local sun, you can begin to carve out a triangle, and lo and behold, you can see how the angles might differ, even if only slightly. And if we take a look at this guy's video, what are the differences in the shadows that he actually finds?
So this is it, okay. Okay, we'll take the measurements in 3, 2, 1, now. I've got I just measured my shadow, and mine was 66.1 centimeters, and then I called Casey, and his was 70.0 centimeters, which means that our shadows are 3.9 centimeters different. Mine is 3.9 centimeters smaller than his is in Regina, which means that the Earth is a sphere.
Okay, pal. So what you can see is, yeah, he's got about 4 centimeters of shadow variance. Again, I'll say it again, this to me supports the local sun flat Earth theory. Because if you were to consider the globe model, how close the two sticks are, at 138 kilometers away, those two basis points for your triangle, and then the top of the triangle is 93 million miles out into space. The sun rays coming to hit those sticks are going to be so minuscule, you will not even see 4 centimeters. I believe that this totally supports the flat Earth theory. And again, he's got his information backwards. On the globe, it should be barely any difference in the shadows, if any at all, that's observable. And what we do see is that there is shadow variance. Now, I know what you're thinking, 138 kilometers. What about curvature? Okay, sure, well, let's go check out the curvature. 138 kilometers turned into miles is about 85.7, so let's take our calculator out here and go 85.7 squared times 8 inches for every mile squared. 58,755 inches divided by 12 is about 4,900 feet of curvature. That's how much curvature there should be in Saskatchewan. So let's just take a look at Saskatchewan and check and see if we can find that curvature. Yeah, I'm not really seeing it. Like everyone will tell you, you can see your dog run away for 3 days in Saskatchewan because it's so flat, right? Look at that. Anyway, that variance in shadow length that we were talking about is indicative of a local light source, which is why sometimes we see the sun and it looks like this.